Hi dear students, today we are going to talk about the distance and the displacement. Let's suppose that an object starts from the point A and travels to the point B. So this is the path of the object as you see in the picture, and if you want to find the distance, so you should measure the length of this path. So the length of the path is distance. And coming to the displacement is the shortest distance between the point A and the point B. So this one is displacement. Let's represent the distance and displacement by using letters. So let's say that the distance is represented by L as the length, and let's say that the displacement is represented by D. So this one is D. And as you see from the picture, which one is greater? Of course, the length of the path, the distance, is greater than the displacement. So we can easily write down that L is greater than distance. So let's discuss if it is possible to have the displacement and distance same values. Is it possible? Yes, of course it's possible. It's only possible when we are traveling by using a straight line from A to the point B. So in this case, as you see, the length of the path is equal to the displacement because it's the shortest distance between A and B. So we can easily write down that the length of the path, the distance, is either greater or equal to the displacement of the object during any motion. In order to understand the essence of the displacement and the distance, let's try to write down an example. So let's say that a car moves from the point A to B, from B to C, and from C to D. And let's give the values. For example, here we have 4 meters, here is 6 meters, and this one is also 4 meters. For this exercise, let's calculate the distance and the displacement. What is the distance in this case while the car moves from A to the point D? So this one is C, yes, and the final one is D. Let's calculate the distance. We said that the distance is the length of the total path. So here you see that we have gone 4 meters, then 6 meters, and then 4 meters. We sum all of them and we get 14 meters. So it means that the distance equals 14 meters. And let's try to calculate the displacement. We said that the displacement is the shortest distance from the initial point to the final point. The initial point is A, and the final point is D. The shortest distance between A and D, we should draw a straight line, so this one is displacement. And you see that this line is parallel to the BC, so they are equal to each other. Then the displacement equals 6 meters. Let's try to have another example, more challenging example. Let's say that this one is example 2. Again, an object starts from K and it travels to the point L. Let's suppose that this one is 8 meters. And after the point L, it travels to the point M, which has the distance from L 6 meters. So the initial point is K and the final point is M. Try to calculate the distance. We said that the distance equals the total length of the path. So L equals 8 plus 6 and equals 14 meters. In this case, the length is 14 meters as well. And try to calculate the displacement. We said that the displacement is the shortest distance from the initial point to the final point. The initial point is K, final point is M, and we draw a straight line from K to M. So this one is displacement. In order to find the length of this straight line, we should use Pythagorean's theorem. So here you have the sides of triangle 8 and 6, and we want to find this one. Let's call it D. So let's apply the Pythagorean theorem. So D squared equals 8 squared plus 6 squared. D squared equals 100 meters, and D equals under square root 100, and it gives us 10 meters. So the displacement is equal to the 10 meters. And in both examples, you can easily see that the length of the path, the distance, is greater than the displacement. And also in the second example, we see the same thing. So the length of the path is 14 meters, but displacement 10 meters, and the distance here is also greater than the displacement. Thank you for your attention.